Welcome to my channel. I'm Zhang Xu. Let's look at the problem 29 in chapter 24. Chapter 24 is about capacitance, dielectrics, electric energy storage. So there we look at this circuit, right? We have C1, C2, C3, C4. 4 capacitors. The capacitance equals to C. We need to determine the equivalent capacitance between A and B. So between A and B, that means we need to find the equivalent capacitors for this whole circuit. So how can we do that? We can see C1 and C2 is series connections, right? And its equivalent capacitance, we can write it as C12. Do you agree? Yes. And C12, we can get it in this equation, right? Because C1 and C2 is a parallel connection. So the equivalent for C1 and C2, C12 must satisfy this equation. And then you can get the function for C12 from there, right? Input C1, C2 inside, you get it is just half of C, right? And then we look at this part, the C1, C2, C3, and then C1, C2 replaced by C12. In this case, we can say C12 and the C3 is a parallel connection. Do you agree? And this can be replaced by equivalent capacitance C1, 2, 3, right? And C1, 2, 3 is the parallel connection C12 with C3. So in this equation, we can get the equivalent capacitance C1, 2, 3 as C12 plus C3, right? And then input the C12 inside, you can get the capacitance for C1, 2, 3. Agree? Yes. Now you can see, we look at the connection C4 with C1, 2, 3 is a series connection. Agree? So this is a series connection. C4 with C1, 2, 3. Series connection must satisfy this equation, and its equivalent capacitance can be written as C1, 2, 3, 4. Agree? So we can write the function look like this one. This is a parallel connection, so it must satisfy this equation. And solve this equation, you get the function for C1, 2, 3, 4, and input the C1, 2, 3, and C4 inside. You get answer there. See? We are solved. The next one, we need to determine the charge on each capacitor and the potential difference across V, right? So next time, we need to find the charge. So how can we do that? So in this case, we write the C12, C1, 3, and C1, 3, 4 at there, right? So we can see, as we talk about, this is C1, C2 can be replaced by C12, right? And then C12 and C3 can be replaced by C1, 2, 3. This is a parallel connection. And C4 and C1, 2, 3 can be replaced by C1, 2, 3, 4. This is a series connection, right? And then we need to find the charge. And we know the charge for Q4 and the Q1, 2, 3 equals, because this is a series connection. See, the charge comes out, goes through C4, and then goes through the capacitance C1, 2, 3, goes back to B, right? This is series connection. So this charge Q4 equal to the total charge and then equal to the Q1, 2, 3. Agree? So the charge is conserved. It flow out from A, so this is Q, right? Flow out and then goes to Q4 at there, and then goes to Q1, 2, 3, and then return to B point. Charge is conserved. Agree? Yes. And this charge can be written as the replacement or the equivalent capacitance 1, 2, 3, 4, C 1, 2, 3, 4 times the total V. Agree? The potential V Agree? And input is C1, 2, 3, 4 inside. You get answer there. So in this way, Q4 is solved. Right? So Q4 is solved. Then we can get the V4. Right? So V4, you can see it's Q4 over C4. So you get the voltages for the capacitor 4 as 3 volts over 5. Right? So easy. The next one, we can see the C4 and the C123 is just a series connection, right? And the charge for Q123 over the capacitance C123 is just 2 volts over 5. See, this V4 plus V123 just equal to V. This is a series connection. Agree? Yes. So now the Q4 and V4 is solved. V comes to there. And we can see inside, this is C123, this is a parallel connection. C3 with C12, right? C3 with C12. And their potential equals, agree? Their potential equals parallel connection. So V123 equal to V3 equal to V12 equal to 2 volts over 5. Right? So in this case, V3 is solved. And also we can see we need to find Q3. How can you get it? You just use C3 times V3. So in this case, Q3 is solved. Right? So Q3 just equal to C3 times V3. So you input the V3 inside. You get it there. Agree? Yes. Now, as we know, the Q123, this charge comes to there, this parallel connection, split in 2 ways. One way is Q3, another way we can call it Q12. Right? So we can see the Q123, so there, Q123 is at there, equal to Q12, this one, plus Q3, there, right? And so in this way, very easily you can get the charge Q12 equal to this Q123 minus Q3, right? You get it there. So Q12 is CV divided by 5. So now it looks like we need to find C1 and C2. And we can see C1 and C2 is a series connection. The charge must equal, right? So the charge equal. So that means the charge Q1 equal to Q2 equal to Q12, right? Just CV over 5. We write it there. So put it inside. Now you can see this Q12 is given and Q1, Q2 is given. Can you find V1 and V2? Yes, because V1 equal to Q1 over C1, right? Input is the Q1 inside, you get answer there. And then look at the V2, we can see Q2 over C2, so you input Q2, you get answer there. Thank you.